Hey, welcome fellas. Welcome to my YouTube channel, I Talk Code. In this series of demystifying Leetcode, I will be discussing the problem path sum of Leetcode. As always, I will be using C++ to design the solution for this problem. Let me read the problem statement for you. The problem link is posted in the description section of the video. So the problem says, given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals to the given sum, keeping in mind that the leaf is a node with no children. So the problem consists of only one input with a boolean output true or false. True if the sum equals the input sum and false if it doesn't. This is a simple problem of recursion. Let me just walk you through the basic complexities for the problem. Remember that we need to design a recursive function to generate all possible path sums. We need to find out the root to leaf path for the tree. Remember, for the root to leaf path, the definition of leaf needs to be very clear. The root node of the tree can't be a leaf. Thus, if the root node has both children null, we straight away return false, as no leaf node exists in the tree structure. Hence, a root to leaf path also does not exist. If the root node has both children null, we straight away return false, as under the following tree. This tree has 5 as the root node and 4 as one child. The other child is null. Now suppose we consider this tree for the problem and we have input sum as 5. Now suppose we start a path from root node 5 and end it at 5 itself and say that such a path with sum 5 is possible. Then actually we are wrong, as the path cannot start and end at the root itself, as root can't be a leaf. Hence, a path to leaf node must end at a particular non-null node. So we get an idea that all valid recursive paths must end not at null but at the not null leaf node. Thus, the terminating base case must end not at null node but at a particular valid leaf node. Our objective is to reduce the size of input at each function call of recursion and reach at a base case, which corresponds to the case of smallest input. As the smallest valid input is when there is a leaf node, the valid base case that returns true should terminate at a leaf node. A leaf node being a node with no children. Also, after including the child node, the remaining reduced input sum must be 0 for a valid true base case. On the contrary, we have another terminating invalid false base condition for a path that ends in a leaf node but results in a non-zero sum value. Now, since the hash path sum function is recursive, it needs to terminate and hence the input to the hash path sum function must decrease with subsequent function calls. Now, since there is a branching of inputs, that is, two parallel and equally possible alternate path of trees, traversal exists for every node in the tree, we need some strategy for considering these two equally possible paths. Now, since hash path sum function being a boolean function should return true or false, we can join two different recursive call statements using the double pipe logical OR operator, thereby telling us that the call to both functions is true even if only one of the conditions is found to be true. But now the question arises that how we can write each of these calls. Since whenever we visit a node, we need to decrease the input sum of the recursive call by the node's value, we subtract the input sum at the call by the node's value, thereby including the node. Also, while traversing, we traverse both ways for the left as well as the right subtree, joining both of these conditions using a double pipe logical OR operation. We also need to use hash path sum as a driver function to first check if the tree is empty and proceed calls to hash path some final function only if the tree is not null and the leaf and root exist. I have posted the working code in C++ in the description section below. I strongly recommend you to use these subtle hints that I post in these videos to help you build your own approach instead of directly jumping onto the solution. Remember, practice is how we learn. Do comment out your approach on this. Any other innovative solutions are always appreciated. I have posted the working code in the description section to help you get even a better understanding. So, if you like these videos, do give it a thumbs up. Share the video with your friends. If you have even a better and a cleverer method to approach the problem, please do comment out your approach in the comment section below. Also, show your support by subscribing to iTalk Code. Till then, happy coding.